basically what I wanted to do first is go over a review of all of chapter 9. So this is going to go by quick. I'm not going to spend a whole lot of time breaking down all of the nitty-gritty parts of it. I just want to go through one problem per section just to make sure you are secure in what you know about linear equations and linear systems. Okay, so let's talk about 9.1. What's 9.1 about? Solving linear systems by graphing. So what do we have here? We have two linear equations. All we want to do is put it onto the graph. Now, personal preference, you have two different ways. The one way would be to use tables, or you could just put it into slope-intercept form. So for me, I am going to solve for y. Why am I going to solve for y? Because that's going to put me in slope-intercept form. What is slope-intercept form? Y is equal to mx plus b. How does that help me? Well, b is my what? Y-intercept. It's a coordinate pair. What is that coordinate pair every single time? In order to be on the y-axis, which is where the y-intercept intersection, the x will always be 0. And what's my y value? It's always going to be that b. So real simple, if I put in slope-intercept form, I at least know I have 1 point. Then what else does it give us? Well, it gives us the slope. The slope is always what? Rise over run. What does the rise tell us? It tells us how far to go up, how far to go down. Or the run tells us to go how far left or how far right. Okay, so let's do that. Let's label this problem number 1. This is problem number 2. I'm going to jump right into it. So 2x plus 2y is equal to 8. What did we say we were solving for? We were solving for y. If we're solving for anything, what do we invoke? The 4 steps. That's exactly right. What does it say? Simplify / combine like terms. So if I'm simplifying / combine like terms, is there anything to do? No. So I move to step 2. Step 2 says remove all addition subtraction from where? Near your variable. I see we're adding a 2x. So I am going to do the inverse, which is subtract. So I am going to subtract 2x. What I do to one side, I must do to the other. How do I know where the sides are? The equal sign. The equal sign will tell me the left side from the right side. Okay? So I have 2x minus 2x. That's just 0. Eliminate it. Go on. 2y. Anything happen to it? No. So just bring it down. Have a positive 2y. Don't forget your equal sign. Anything happen to the 8? Nope. So bring it on down. Then I have this negative 2x. So bring it on down. Nothing happened to it. Is y alone? No, it is not. So I do step 3. What step 3 say? Remove all multiplication and division from where? Near your variable. That says 2 times y. So what am I going to do? I'm going to do the inverse. So that is division. The opposite of multiplication is division. So I'm going to divide by a 2. What I do to one side, I have to do to the other side. The whole thing. Not just a portion. So every term on the other side I have to divide by 2. So what does that tell me? 2 divided by 2 is just 1. So I get y. Don't forget your equal sign. Now watch this. 8 divided by 2. 8 divided by 2 is 4. Negative 2 divided by 2 is a negative, because a negative and a positive. But 2 divided by 2 is 1. And then I have an x. Do I really have to write the 1? No, but I'm just writing it so we can make sure that we have it. Now, I'm looking at this equation. It's in slope-intercept form, but I like to rewrite it just to make sure that it matches up. So I get y equals negative x plus 4. Now watch. Y equals mx plus b. There we go. It all matches. So we can literally look at it and say, okay, the b is equal to 4. What's this number in front of the x? It's a negative 1. My slope is negative 1. And then you can clearly see right here, x is with x, y is with y. They totally match up. So now I told you, Slope-intercept form gives us something. Tells us what the y-intercept is. So the y-intercept for this equation, remember, x is always 0. The y is going to be what? 4, because that's what the b is. It also tells us the slope. What is the slope? -1. If I want to make that a fraction, I just put it over 1. So that tells me to do what? Go down 1 and to the right 1. So I'm going to go down 1 and to the right 1. So let's go ahead and graph that right now. So we're going to come over to the graph. My y-intercept is 0, 4. So here we go. Here's 0 on the x-axis. Here's 4 on the y-axis. Now, the slope told us to go down 1 and to the right 1. So then I'm able to plot my second point. After I'm able to plot the second point, all I have to do now is connect the two dots, which gives me a straight line. Okay, I'm trying to make it as straight as possible. Let me just deal with some of these technical difficulties with OneNote sometimes when drawing lines, but we have that. So there we go. So here's the best thing about math, at least in my opinion. I'm going to do the same exact steps. I'm just going to do it to a different problem. So here's problem number 2. Equation number 2, it says x minus y is equal to 4. And now all I have to do is focus on this one problem. And what am I trying to do to it? I am going to solve for y. Why am I going to solve for y? It's going to put it in slope-intercept form. And we need slope-intercept form, okay? So here we go. Circle the y. Whenever I'm solving for something, I do 4 steps. Simplify / combine like terms. Nothing to do. Step 2. Remove all addition, subtraction from near your variable. I'm adding an x, so I'm going to do the inverse. So I'm going to subtract that x. What I do to one side, I must do to the other. So I put it on the other side. I keep everything in its own columns and just work my way left to right now. X minus x, 0. Bring down the negative y because nothing happened to it. Don't forget your equals. Anything happened to the 4? Nope, just bring it down. Nothing happened to the negative x, just bring it down. Is y alone? It looks like it, but it's not. There's a -1 right there. And what that says is -1 times y. And what step 3 do? Remove all multiplication and division from near that variable. So I want to do the inverse of the multiplication. So I'm going to divide by -1. What I do to one side, I must do to the other side. So -1 divided by -1 just gives me 1. So I have y equals, now watch this, 4 divided by -1 is -4. What's this number in front of the x? It's a -1. -1 divided by -1 is a +1. So I just get plus x. Now, for me, using a commutative property, I'm able to sit there and switch these two around, and I will put it into x minus 4. Why? Because it lines up. Y is equal to mx plus b. Now watch this. B is equal to -4. Very visible. What's the number in front of the x? It's a 1. So my slope is 1. X lines up with x, y lines up with y. I know that this is a perfect match. So what does it give me? Y-intercept is created because of the b. So I have 0 for the x. What goes in for the y? Well, the b. The b is what? -4. What is my slope? My slope is equal to 1. How do I make that into a fraction? Put it over 1. So what does my slope tell me to do? Go up 1 to the right 1. So I want to go up 1, right 1. Okay, so let's graph it. 0, -4 on the graph. Let's do it. Here is 0 on the x-axis. -4 on the y-axis is right there. It tells me to go up 1, right 1. So I'm able to draw another point. Once I have 2 points, I can create a line. And once I create that line, where is my solution? It's where they cross. Here we have solving linear systems by substitution. This one's different. Okay, so what do we have to do? We need to, again, we're just going to solve for y. Why do we solve for y? Because it puts us in slope-intercept form, which allows us to graph it with ease and everything else. But because we're using substitution, we need to solve for one of the variables. It could be any one of these variables, but we're going to solve for y because it gets us in the habit of always putting these equations in slope-intercept form. Okay, so now solve for y. What's the easiest one to do that to? This second equation, because the coefficient's just a -1. So let's do that. So x minus y equals 4. If I ever want to solve for anything, what do I use? 4 steps. So here we go. Solve for that. Simplify / combine like terms. Anything to do? No. Step 2. Remove all addition subtraction from near your variable. Yes. I need to do the inverse, which is subtraction of this x, because I'm adding x. What I do to one side, I must do to the other. Real simple there. Now just go left to right. X minus x is 0. Anything happening to the y? Nope. So make sure you bring down that negative. You get -y equals, anything happening to the 4? Nope. And then just bring down the -x. Is y all alone? Looks like it, but it's not. There's a -1 sitting right there. Okay, so step number 3, what are we going to do? Remove all multiplication and division from where? Near your variable. This says -1 times y. So if I do the inverse, I'm going to divide. Divide by what? -1. What I do to one side, I must do to the other. Now it's real simple. -1 divided by -1, y. 4 divided by -1 is -4. What's this number right here? It's a -1. -1 divided by -1 is a +1. So I just get positive x. You don't even have to write the 1 right there. Does that make sense? Now, since y is all alone, y is equal to x minus 4. So if y is equal to x minus 4, isn't it true for this one that y should also equal x minus 4? So now we can do what? Substitute. Okay, so we're going to take this original problem, 2x plus 2y is equal to 8. We just said that y is equal to x minus 4. So if that is true, I can take this and substitute it in for that y. And how do we substitute that in? Always use parentheses. Keeps it nice and clean. So 2x plus 2 parentheses. What do we put in the parentheses? What y is equal to? Y is equal to x minus 4 is equal to 8. Now what are we going to do? We are going to solve for x. Notice I have 2 circles there. Automatically, you know you're going to have to combine like terms because you've circled 2 different variables. But let's go through the process. Step 1. Simplify / combine like terms. Simplify. How do I simplify? PEMDAS. Anything to do? No. Step 2. Distribute. Yes, I can distribute. I can distribute this 2 in to the parentheses. So I'm going to distribute. So my new equation is 2x plus 2 times x is 2x. 2 times the -4, -8 equals 8. Notice I still have these x's here. Always go through your step number 1. So again, what are my 4 checklist items? PEMDAS, anything to do? No. Distribute, anything to do? No. Remove fractions, anything to do? No. Factor, anything to do? No. What's left? Combine like terms. Yes, I have 2x plus 2x. I can combine those, same family. So I get 4x minus 8 equals 8. There we go. Now they're all combined. Anything left to do for step 1? Always check it just again. There's nothing to do, so I move on to step 2. Step 2 says remove all addition subtraction from where? Near your variable. I see a subtraction here, so I'm going to do the inverse. I'm going to add. So I add 8, add 8. So now, here we go. 4x right there. Negative 8 plus 8, 0. Don't forget your equal sign. 8 plus 8 is 16. So here we go. Step 3 says remove all what? Multiplication and division from where? Near your variable. So I am going to divide because that's the inverse of multiplication. So what I do to one side, I must do to the other. So I get x is equal to 4. Does that make sense? So now, I know that y is equal to x minus 4. I know x is equal to 4. So now, I can substitute again. Y is equal to x minus 4. And I know that x is equal to 4. So if I substitute this in for that x, let's do it again. Y equals, put parentheses when you substitute in, 4 minus 4. Now to solve for y, you only got one step, PEMDAS, because they're all constants. So y is equal to 0. So what you're telling me is when x is equal to 4, y is equal to 0 for both problems as my solution. Now, I can sit there and write that as a coordinate pair. 4, 0 is my answer. And that's how we do substitution. Okay? Overview of what we just did. What did we do? We solved for y in one equation. After we got whatever y is equal to, which could be an expression, it could be a constant, we substitute that into the other equation. And what did we do there? We solved for the other variable, which was x. Okay, once we solved for x and we knew what x was, what did we do? We substituted back in to the first equation and did what? Solved again for y, which was pretty simple. And once we knew what x and y was, we were able to get an answer. And what was the format of our answer? It was some kind of coordinate pair. And this is where both equations are what? True. Now, what does that look like if we sat there and graphed them? It's where they intersect. Okay? Hopefully that ties that all together as we go through, but we just did nothing but the numbers when it comes to substitution. When it comes to 9.3, we are going to do what? We're going to solve linear systems by adding or subtracting. This is just the elimination method, okay? So I call it the box method because I want you to put a box around the variable you are going to eliminate. How do I know which one to eliminate? Well, I am going to look at the coefficients. Whichever one has a coefficient that is either equal or inverses of each other, that is the variable I am going to eliminate. So if you look here, the coefficient for this x is 2. The coefficient for this x is negative 2. They are inverses of each other. They're exactly the same in the sense of the coefficient 2, but they're inverses because one's positive, one's negative. Here, the coefficient's 2. Here, the coefficient's negative 1. So which one am I going to eliminate? I'm going to eliminate the x because 2 and negative 2 are inverses of each other. How am I going to eliminate that? Well, since they're inverses of each other, which means they're opposites, I can add these equations. And I just draw a line, just like that. Go from left to right and add them. 2x plus negative 2x goes to what number? 0. And that's why we call it elimination. It goes to 0. We know that 0 is nothing. So now I add the next column. 2y plus a negative 1y. So that really just says 2 minus 1. 2 minus 1 is 1. So I have 1y. Then don't forget your equal sign. And now 8 plus 4 is 12. And if you look, 0 doesn't really account for anything. I have y equals 12. Now that I know that y is equal to 12, what can I do? I can substitute it back in. Does it matter which one I substituted in for? No. Which one's the easiest one though? I would say the second one. So here we go. Negative 2x minus y equals 4. What is that y equal to? A 12. So let's make sure when we substitute, always use what? Parentheses. And I get it in there. Now, what are we going to solve for? X. Whenever we're solving for something, what do we use? 4 steps. So here we go. Simplify slash, combine like terms. Anything to do? Not really. This really, I can rewrite it. Negative 2x minus 12 equals 4. But there was really nothing for me to do there. So now, step 2, remove all what? Addition and subtraction from where? Near this variable. There's subtraction. So what am I going to do? The inverse, which is add. So I add 12. What I do to one side, I must do to the other. Notice I can put it underneath the 4 because they're in the same family. So here we go. Anything happen to the 2x? Nope. So just bring it down. Negative 2x. Negative 12 plus 12 is 0. Don't forget your equal sign. 4 plus 12 is 16. Step 3. Remove all multiplication and division. There's a negative 2 there, so I'm going to do the inverse. I'm going to divide. Divide by what? Negative 2. So what I do to one side, I must do to the other. So I got negative 2 divided by negative 2. That leaves me with an x. 16 minus 2, 16 divided by a negative 2 is a negative 8. Now I know that x is equal to negative 8. So x equals negative 8. I know that y is equal to 12. I know that x is equal to negative 8. What is my answer? Remember, write your answer in coordinate pair. X is always first. It's in alphabetical order. You shouldn't mess that up. So xy. So here we go. Negative 8. What's y? 12. So my answer is negative 8, 12. These two equations are true or intersect at the same point, which is negative 8, 12. So now, how do I know when to add? I add the equations when what? The coefficients are what? Inverses. Does that make sense? So when would I subtract? Well, good question. Let's look right here. I have 2x and a 2x. Those are exactly the same coefficient. Here I have a 2 and a negative 1. These aren't inverses, but they are exactly the same. Now watch what I do. I am going to eliminate the x because 2 and 2 are exactly the same. But I can't add them. If I add them, I would get 2x plus 2x, which is 4x. Nothing was eliminated. So if they are exactly the same coefficient, I will subtract. Now, potentially you could just rewrite this and add them if you wanted to, depends on the way that you think, but I am going to subtract each one of these. Okay, so this is what it looks like. 2x minus 2x is 0. 2y minus a negative y, a negative and a negative is a positive. So I'm really saying 2y plus y is 3y. Then don't forget your equal sign. This says 8 minus a negative 4. So a negative is a positive. So I get 8 plus 4 is really 12. So let me rewrite that so you can see it. What I really did was distribute a negative on this bottom row. So it looked like this. 2x plus 2y equals 8. That's just the original top. Well, on the bottom, I really got negative 2x plus y equals positive 4. And now, because these are inverses, I can just add them. So 2x plus a negative 2 is 0. 2y plus that, I get 3y. 8 plus 4 is 12. Same exact thing, okay? So hopefully that makes sure that you understand how we distribute that negative all the way through. Now, I'm going to solve for this y. How do I solve for anything? 4 steps. Nothing to do on the first one. Nothing to do on the second one. The third one, that's 3 times y. So I'm going to divide. By 3, divide 3. Y is equal to 4. So if y is equal to 4, what do I do with that? I can substitute it back in. Does it matter which one? No. But I'm going to take the bottom one too anyway. So here we go. 2x minus y is equal to a negative 4. That's the original problem. What I'm going to do, I'm substitute this 4 in for that y. So 2x minus, use parentheses when you substitute, equals negative 4. Now, I'm going to solve for this y. So just to make sure that this is clear, that's nothing happening right there. I get 2x minus 4 is equal to negative 4. So what's the first step say? Simplify / combine like terms. Anything to do? No. Step 2, remove all addition and subtraction from near your variable. There's subtraction. So I am going to do the inverse. I'm going to add. So I add 4, add 4. Because what I do to one side, I must do to the other. So I get 2x, nothing happened to it, so bring it down. Negative 4 plus 4, 0. Don't forget your equal sign. Negative 4 plus 4 is what? 0. Don't forget to write it. Still okay. I'm worried about the x. So here we go. 3 says remove all multiplication and division from near your variable. So what am I going to do? I'm going to divide because this says times. 2 divided by 2 is just 1, so I get an x. 0 divided by 2 will always be 0. So look at this. I know that y is equal to 4, x is equal to 0. So what is my answer? If x is 0, y is 4, then my answer is what? 0, 4. Does that make sense? So both of these equations, this 2x plus 2y equals 8 and 2x minus y equals negative 4, if we drew a graph of both of those lines, they would intersect exactly at 0, 4. Does that make sense? So how do we know when to subtract? We subtract when the coefficients are what? Exactly the same. Are the same. Okay? Does that make sense? So all of this means in 9.3, solving linear systems by adding or subtracting, you need to know when to add or subtract the equations. So first things first, stack them. Put the x column, the y column, and coefficients. This is just standard form. Okay. Then I check the coefficients. I look for if they are inverses or exactly alike. If they are inverses, then that means a positive 2 and a negative 2. Then I will add the two equations. If they are exactly the same, positive 2 here, then I will subtract the equations, which really just means I'm going to distribute the negative to the bottom half and be able to sit there and solve for one of the variables. What is the box for? It just keys me in. It makes me understand that I am going to eliminate, which means go to 0 one of these variables. Okay, cool. Okay, so let's go to 9.4. 9.4 says solving linear systems by multiplying, which really is the elimination method, okay? So this elimination method includes one more step, and then we can revert back to the elimination method of adding and subtracting these equations. Again, what format are these in? They're in standard form, okay? Now, what are we going to check immediately? We're going to look at the coefficients, and we're looking to see if they are additive inverses of each other. So this 2, what's this x? What's the coefficient of the x? It's really just the 1. Okay, I look at this. This is a 2. And the coefficient of this y is a negative 1. I can't add them or subtract them because neither one, they're not equal to each other and they're not additive inverses of each other. So I have to do one more step. I can change one of the equations or both until I can get an additive inverse for one of these coefficients. What does that even mean? Okay, that means I either want this one to be exactly like the one above it, or I want this one to be exactly like the one above it. Okay, so what are we going to do? How do I get this negative 1 to become a negative 2, which would be the additive inverse of that 2? Well, I need to multiply it by a 2. Now, here's the laws that govern math. You can't just all willy-nilly just sit there and multiply that by a 2. So what are you going to do? You are going to multiply the whole thing, both sides, by a positive 2. Now watch what happens. I distribute this in. 2 times that x, 2 times that negative 1y, and 2 times the 4. And that keeps it equal. It will be the same exact equation. So let's just rewrite it so we're nice and neat. I have 2x plus 2y is equal to 8. Now, let's look at the bottom one. We're going to change the bottom one. It's no longer just x minus y equals 4. It's 2 times that x, which gives me 2x. Let's put that in a different color so we know that we have a new equation. I get 2x. 2 times a negative 1 is a negative 2y. And then 2 times 4 is what? 8. Now look at this. Remember what we said. If I want to eliminate one, I put a box around it. And I put a box around the y's because the 2 and the negative 2 are additive inverses. There we go. If I have an additive inverse, what am I going to do to the equations? I'm going to add them together. So 2 plus 2x is 4x. 2 plus negative 2y is 0. Don't forget your equal sign. 8 plus 8 is 16. And look at that. You eliminated the y, so now you only have one variable, and you are now able to solve for it. If I'm going to solve for x, what am I going to do? 4 steps. You got it. Simplify / combine like terms. Anything to do? No. Remove addition and subtraction from near my variable. No. Step 3, remove all multiplication and division from near your variable. That says 4 times x. So I'm going to do the inverse. I'm going to divide. Divide by 4. Divide by 4. 4 divided by 4 is just 1. I get x equals 4. Now, look at this. I know that x is equal to 4, but I don't know what y is. What can we do? We can substitute it in. Does it matter which equation you substitute it in for? No. So here we go. Let's just pick the top one. So it's 2x plus 2y is equal to 8. We know that x is equal to 4. What do we do with that? Substitute it in. So let's rewrite it. 2 parentheses, use parentheses every time you use substitution, plus 2y equals 8. Now I only have one variable. Since I have one variable, I can solve for it using the what? 4 steps. See how it just keeps repeating itself. All right, so here we go. Simplify / combine like terms. Yes, I need to simplify. I have PEMDAS. 2 times 4. What's 2 times 4? 8. And then I just get 2y is equal to 8. What's step number 2? Remove all addition, subtraction from where? Near your variable. So I'm going to do the inverse of it. I'm going to subtract. What am I subtracting? This 8. That says 8 plus. So I'm going to subtract the 8. What I do to one side, I must do to the other. I can put this underneath the 8 because they're both constants. So 8 minus 8 is 0. Anything happen to the 2y? Nope. I get 2y. Don't forget your equal sign. 8 minus 8 is 0. Remember, focus on your variable. Step 3. Remove all what? Multiplication and division. From where? Near your variable. That says 2 times y. So I'm going to divide. I divide by 2, divide by 2. 2 divided by 2 is just 1. I get y equals, what's 0 divided by 2? 0. Piece of cake. So now, you told me x is equal to 4. Now you found out that y is equal to 0. So what is your answer? My answer is in a coordinate pair. So x is equal to 4. Y is equal to 0. So at exactly 4, 0, both equations would be true. Or what does that really mean if I graph them? It means that they would intersect at exactly 4, 0. Okay, 9.5, almost done. 9.5, solving systems of linear inequalities. Okay, so let's do a quick review on an inequality. Now, if I have greater than or less than, that means that the line is going to be what? That's right, dashed. You create a dashed line because that means that any of the values on the line are not included in the answer. If I have greater than or equal to or less than or equal to, the line is what? Solid. Does that make sense? So that means that any of the points that are on the line are actually included in the answer. Now with inequalities, if we're trying to solve the equation, there's going to be some sort of shading, okay? So we have to make sure that we understand what we're doing there. But other than that, we're going to treat this just like any other problem. So how do I graph an inequality? I'm going to solve for y. Right now, they're both in standard form. If I solve for y, what am I going to be in? That's right. I'm going to put them in slope-intercept form. Okay. If I put them in slope-intercept form, I will know at least what? 1 point, which is the y-intercept. I'll also know the slope, which will give me the second point. So let's do that to the first problem. I have x plus y is greater than 10. Now, some people get nervous about the whole inequality thing. Just treat it like an equal sign if you have to and do the 4 steps. So here we go. Step 1. If we're solving for y, what does it say? Simplify / combine like terms. Anything to do? Nope. Step 2. Remove all what? Addition and subtraction from where? Near your variable. So I'm going to subtract. Why? Because I'm adding an x. So I subtract the x. What I do to one side, I must do to the other. How do I know the difference between the sides? The inequality separates the left from the right. So here we go. X minus x, 0. Bring down the what? Y. Don't forget your inequality, greater than. Anything happen to the 10? No. Anything happen with x? No. So there we go. Is anything else next to my y? Nope. So I'm going to treat this just as if it had an equal sign, and put it into slope-intercept form by saying y is greater than, instead of the 10 first, I'm going to put negative x plus 10. Now watch this. What does it look like? Y equals mx plus b. So that means b is 10. That's a negative 1, correct? So the slope is negative 1. The x lines up with the x. The y lines up with the y. The only difference is that we have an inequality. Okay? So here we go. What is my y-intercept? We know that x will always be 0 for our y-intercept. So what is the y value? Well, it's b, and b is equal to 10. What is equal to my slope? My slope is negative 1. How do I make that into a fraction? Just put it over 1. So what does that tell me to do? It tells me to go down 1 and to the right 1. So I'm going to go down 1, right 1. Does that make sense? So let's go ahead and do this one problem by graphing it right now. So 0, 10, down 1, right 1. Okay? So here's our graph. 0, 10. Well, here's 0 on the x-axis. And where's 10? All the way up here. There we go. We got 0, 10. Then it told us to do what? Go down 1, right 1. And put another what? Point. Just like that. So now I can draw a line. Okay. So here is the difference between just drawing a line, which is a linear equation, and a linear inequality. Remember that greater than sign? We have to deal with that. Greater than. So this is how I teach it. If you have a line, just draw a vertical line on it. Okay? So it doesn't matter where you are on the line, just draw a vertical line. Line that goes straight up and down. Now you tell me, is this arrow greater than, or is this arrow pointing to greater than? Of course. Up is always greater than, correct? So we are going to shade that area. So anything on the graph that is in that area will be a solution. Now, we also have to deal with one other thing. It said greater than. Greater than means that we have to use a dashed line. So what do I do with this blue line? Really simple. I take a nice little eraser and I make it dashed. And what does the dash mean? It means that anything that's on this line is not part of the solution. Okay? That's how simple that is. So let's go over those steps real quick. I know my equation. My equation was what? Y is greater than negative x plus 10. So my y-intercept was 0, 10. So I plotted that right there. My slope was negative 1 over 1. So I was able to get my second point, down 1, right 1. And then I made a dashed line because this is just greater than. Okay, greater than. Then I know that I shade above the line because the arrow on the vertical line was pointing to the greater side. Okay, does that make sense? So that's how you do a linear inequality. Now, here's the thing. We're in a system, so we have to repeat those steps one more time. So let's go to our second equation. Our second equation is right here. X minus y is less than or equal to 4. So, with that being said, you already know because it says less than or equal to, you're going to have what? A solid line. Whoop. Wish I knew how to spell sometimes. But a solid line. Okay? We also know that we're going to shade where? Below. So without even doing anything, I know those two things for sure. Now, we have to do what? Yes, solve for y, because that's going to be the easiest way to graph. Okay, so here we go. X minus y is less than or equal to 4, and I'm solving for y. I'm going to do the 4 steps. Here's the 4 steps. Simplify / combine like terms. Anything to do? No. Step 2, remove all addition and subtraction from near your variable. What am I going to do? I'm going to subtract, because there's an x right there that's added. So what I do to one side, I must do to the other. X minus x, 0. Bring down the negative y. Keep your less than or equal to sign. Bring down the 4, and I have a negative x. Is the y all alone? Nope. So I'm going to do step 3. Step 3 says remove all what? Multiplication and division. That's a negative 1. So I am going to divide. So what am I going to divide by? Negative 1. What I do to one side, I must do to the other. Now, put a big star here. Anytime that you divide by a negative number, and we're talking about with inequalities, okay? You must do what? Exactly. You must flip the sign. Okay? That's very, very important. But that's only if you divide or multiply, but divide by a negative number. I'm dividing by a negative 1. It says it right there. Okay? So negative 1 gives me 1. I still get a y. 4 divided by negative 1 is negative 4. Here's a negative 1 here. Negative 1 divided by negative 1 is a positive x. But here's the thing. Instead of having less than or equal to, I now flip the sign to be what? Greater than or equal to. So I need to come back up here. I'm not going to shade below the line. I'm going to shade where? Above the line now. Does that make sense? Okay. So here we go. I know that y is greater than or equal to, and remember, we usually sit there and use the commutative property for this by flipping the x. So I get x minus 4. So it says y is greater than x minus 4, which is in the same format as our what? Y equals mx plus b. So our b is 4. What's this number here? 1. So our slope is 1. And the x lines up, y lines up. I'm all good. So what is my y-intercept here? Y-intercept is going to be what? 0 for the x always. B is equal to what? Negative 4. So we're good there. What's my slope? My slope is 1. So I make it into a fraction, put it over 1. It tells me to do what? Go up 1, right 1. So I'm going to go up 1, right 1. Real simple. All right, here we go. Let's graph. So I get 0, negative 4. So that's the 1. Now I'm going to go up 1, right 1, right there. And that allows me to plot my second point. So what do? I'm going to draw a line. What kind of line are you going to draw? It's going to be solid. Why is it solid? Because it's greater than or equal to. Greater than or equal to is solid. Now remember what I said. For inequalities, these are for inequalities. There has to be some sort of shading. So I am going to draw a vertical line. If I draw a vertical line, greater than or equal to, isn't that arrow pointing to greater than? Yes. So what are we going to do? We are going to shade everything that is above that line. Now watch this. Everything above the line is all true. Does that make sense? Okay. So let's do it again. Let's make sure that we did it right. I have a greater than or less, a greater than or equal to sign. So that means that I'm going to have a solid line. Cool? Now, since I have a solid line, I have that. Cool. I know that the y-intercept is 0, -4. Plotted that correctly. I know that the slope is up 1, right 1. Plotted that correctly. I drew my line. Then I need to shade where? Above the line because it's greater than or equal to. I drew my little vertical line. There we go. I have the arrow pointing to greater than. I shade it. So where is the solution for both inequalities? Well, obviously, you guessed it. It's where they're both true, which is here where they're double shaded. Not where it's just yellow, not where it's just pink, but this red where it's double shaded. Does that make sense?